Welcome back, Prep Station Physics, UTME 2025. All right, so we're on the fourth question. Which of the following physical quantity is not a vector? Okay, I told you the answer is work. Why is the answer work? Because vector quantities are characterized by what? Magnitude, unit, and direction. So this does not have direction. For example, heat energy is a quantity. Okay, it has no direction. Heat can flow in any direction. So let's go to the next question. An example of a scalar quantity. You should know this by now. An example of a scalar quantity. Of course, momentum is not, acceleration is not, velocity is not, weight is not. So that should be electric charge. That should be electric charge. All right, let's look at another question. Which of the following is a set of vectors? Set of vectors. Okay, force. Okay, let me use my marker here. Force is a vector, mass is not, moment is. So that cannot be the answer. Acceleration is a vector, velocity is, moment is. What about mass? No. Weight? Yes. Density? No. What about mass? No. Volume? No. Density? No. So the answer here is B. B is a set of vectors. That's correct. So which of the following is a set of vector? B is a set of vector. All right, let's look at another one. A boat travels due east at a speed of 40 meters per second across a river. A river flow due south at 30 meters per second. What is the resultant speed of the boat? Okay, to answer this type of question, you need to make a little sketch. A boat travels due east. So you can do this. Start by drawing the cardinal points, okay? Due east is to my right, so the boat is going due east. Put your arrow to show that it's a vector, and then 40 meters per second. And then what happened? The river is flowing due south. So from the tip of the last vector, put the second one. So the river is flowing south at a speed of what? 30 meters per second. So what is the resultant speed? The resultant speed will be a line drawn from where? Starting point to where? End point. So if you like, you can use dashed line for this. Now ask yourself, what type of triangle is this? This is a right angle triangle. So with this, we are free to use Pythagoras theorem. So let's call this R, resultant. So if that is R, then I can say R squared will be equal to 40 squared plus 30 squared. Of course, if you have your calculator, just do this with me. 40 squared is 1,600, and then 30 squared is 900. And then if you continue, then you get 25, and then 0, 0. Okay, so of course, R will be the square root of 2,500. So therefore, the answer we are looking for is square root of, so that will be 50 meters per second. So the answer should be 50 meters per second. That is how to solve it. So 50 meters per second, that's correct. Let's move quickly. Question 8. Two forces of 10 Newton act on a body, one towards the north and the other towards the east. The magnitude and the direction of the resultant force are the same method. Ensure to start with your cardinals, just something like a small cross, and then represent the vector one after the other. Two force, each of 10 Newton acts on a body, one towards the north. So let's start with north. One is towards the north and is 10 Newton force, okay? Then the other towards the east. My right hand is east, so ensure that the second vector starts from where the tip of this one stops. So this is the second vector, and is also 10 Newton. So what will be the resultant force? A line drawn from this point to this point. Okay, so what will be the resultant? Let's call this R. Okay, so if that is R and this is a right angle triangle, so I can use Pythagoras theorem. So R squared will be equal to 10 squared plus 10 squared. This will give us 200. So R will be equal to square root of 200. So R will be equal to square root of 200. And then if you work on this, you are going to get 10 root 2. 10 root 2. So what will be the angle here? What will be the angle here? Even without calculation, since this is 90 degrees, this is 10, this is 10. That makes it an isosceles triangle. So if it's an isosceles triangle, it means this angle is equal to this angle, and that will be 45. So the vector we are looking for is 10 root 2 Newton. Now, what are these cardinals? North and east. So that will be north 45 degrees east. So this should be the answer. Although this was represented in some kind of notation, so this should be the answer. 10 root 2. This means square root of 2. Okay, 10 root 2 Newton, then north 45 degree east. I want to believe that was simple enough. East, okay, west, I mean. Now let's go. If the angle between two vectors P and Q is 0 degrees, the vectors are said to be what? Very simple question. Now, the only condition for vectors to have angle of 0 is if they are parallel. Do you know why? Because an angle is formed when two lines meet at a point. Angle is formed when two lines meet at a point. So if two lines cannot meet, it means they are parallel. If two lines cannot meet, it means they cannot form an angle. So the only condition for P and Q to be 0 is when they are moving parallel. So the answer here should be C, when they are parallel, not perpendicular. That's correct. So if the two vectors are parallel, the angle between them will be parallel. All right, the last question. The component of vector x along the direction of vector y is 0. When what happened? When what happened? It's still the same question, but probably framed in another way. So the component vector of x along the direction of y is 0 when x and y are what? Parallel to each other. I want to believe that was clear enough. So let's move to another topic quickly. So we now go to lesson 3, and here we want to look at linear motion. One of the most popular topic in physics, linear motion. Linear here means straight line motion. So we'll be looking at just 4 subtopics under this, okay? So we look at types of motion, we look at causes of motion, types of force, and then the equation of motion for linear motion. All right, so let's start with the types of motion. Okay, the study of the different types of motion exhibited by a body is called kinematics. Kinematics. While the study of the force associated with each type of motion is called dynamics. So to study the different types of motion exhibited by a body, we call it kinematics. So an object is in motion when its distance from another object is changing. An object is in motion when its distance from another object is changing. In other words, we are saying that motion is what? The change in position of an object, okay? When you change position from point A to point B, it means motion has taken place. There are 4 types of motion. Yeah, basically there are 4. Although sometimes if you go on the internet, you see like 8 and 7, but whatever you see there, they are grouped under these 4. There are basically 4 types of motion. Number 1 is called circular. You can call it circular or you can call it rotational motion. rotational motion. Circular or rotational motion. Number 2 is called oscillatory. You can call it oscillatory or you call it vibratory motion. Vibratory motion, which is known as to and fro. And then the other part of it is what is called a simple harmonic motion. If the to and fro motion becomes periodical, then we can refer to it as simple harmonic motion. Then number 3 is translational motion. Translational motion is also what we call the linear motion, translational. And then the last one is called random motion, or you can call it zigzag motion. Okay? Now, zigzag motion. Now, circular motion or rotational. Now, what is circular motion? When an object moves in a concentric circle, when an object keeps going about a particular point in concentric circle, you call it what? Circular or rotational motion. Then number 2 is oscillatory, vibratory. Example of oscillatory motion is simple pendulum. When an object moves to and fro about a particular point, you call it vibratory oscillatory motion. And then number 3 is called translational motion. Now, what is translational motion? It is the motion of a rigid body. For example, how did I get to this place? Through a cap. Now, what was I doing inside the cap? Was I rotating? No. Was I jumping? No. What was I doing? I just sat one place with my seatbelt crossed. But along the line, I was able to do what? Undergone motion. Why? Because the motion of the car has been translated to me. So the motion of rigid body is known as what? Translational motion. Then number 4 is random motion, also known as what? Zigzag motion. When an object undergoes motion without direction, it is called zigzag motion. For example, the diffusion of gas, the diffusion of smoke, the movement of dust particle in air is called zigzag or random motion. So let's move. Now, what do you think are the causes of motion? What exactly is the cause of motion? Very simple. According to Newton's first law of motion, we have about 3 laws of Newton, 3 Newton laws of motion. But according to the first law, which is also known as the inertia law, inertia law. Inertia here simply means unwillingness. Unwillingness. Inertia means unwillingness. When an object is not ready to move, or when an object is not ready to stop when it's moving, that is what is called inertia. So according to Newton's first law, it takes force to start motion. It also takes force to stop motion. So if an object is resting, if an object is at a state of inertia, resting, it's not ready to move, you need force to make it move. And if an object is moving and it's not ready to stop, you need force to make it stop. Of course, that is what is known as Newton's first law of motion. So it takes force to make motion happen. It takes force to make motion stop. Okay, let's move forward. The study of the different types of motion exhibited by a body is known as kinematics. I explained that before. While the study of the different forces associated with a type of motion is known as what? Dynamics. For example, the force responsible for rotational motion is not the same force responsible for simple pendulum. It's not the same force responsible for linear motion. The force responsible for rotational motion is called centripetal force. Centripetal force. But the force responsible for oscillatory motion is called restoring force. So you can see they are not the same thing. So the study of the forces associated with different types of motion is what is called dynamics. Okay? So We're going to take a short break. When we're back, we look at types of forces.